In this video, we are going to discuss how an alternator can be used as a dummy load. This is the alternator with 2 ports. This is a dummy load, 1 port. In RF test and measurement, it is quite often that the dummy load is needed for termination. And also quite often, there is no dummy load in hand, or more dummy loads were needed. However, there may be more alternators available. Is it work if I use the alternator as a dummy load? The answer is yes. It works with some conditions fulfilled. What are the conditions? First, the alternation of the alternator must be high enough, at least 15 dB. And then the second condition is the power rating of the alternator must be higher than the RF power feed to its input port. For example, if your power from your transmitter is 10 watts, and then the alternator's power rating only 5 watts, then you can't use it. Otherwise, you'll burn it. Okay, let's check the details in the following slides. First, let's see if we have RF power in from here to the input port of the alternator. And then we don't have dummy load to terminate the output port of the alternator. So this worst case, leave it open. And what will happen, the power feed from here come to here is open port, then all will be reflected back. So the power from here to the port with 20 dB loss, then reflect back to the input port with another 20 dB loss. So total there will be 40 dB loss. Based on this formula, 40 dB loss equivalent to the VSWR of 1.02. Okay. This is you can see if we only consider this one, this VSWR is very close to 1. So if we use it as a dummy load, there will be no problem if the power rating is high enough. And if you compare the dummy load here, for example, the dummy load, this one, the frequency from 0 to 4.3 gigahertz, and then the VSWR is 1.07, higher than this here. But it's not that simple, because the alternator itself also with VSWR bigger than 1, because even though you have a dummy load terminated here, the power still be reflect from the input port directly back to your RF source here. Let's check the data sheet of one of the alternator. This one, the frequency range is DC to 18, and it's 50 ohm, and then the VSWR. Let's look at it. For example, at the 6 gigahertz, it is 1.08. So it's bigger than higher than what we calculated just now, 1.02. This is the VSWR of the input port alternator. So let's consider the combination of this VSWR together with this VSWR, or together with the power reflected back from here. So if we only consider the VSWR of 1.08 of the alternator, the return loss is 28.3. Based on this formula, we can calculate it. If you are interested, you can do some of maths here. And then this 28.03, if we feed 1 watt of the RF power to this alternator, the return power, reflected power, is around 1.5 milliwatt. Then this 20 dB alternator is connected as a dummy node, and the output is open. So as we just discussed, the total 40 dB loss. So some 1 milliwatt power will be returned. That means if 1 watt come in from here, then send to here, then reflect back. Roughly 1 milliwatt will back to here. So total 1.5 plus 1 milliwatt, 2.5 milliwatt power will be reflected at the input port of the alternator. So the return loss will be calculated based on this one. 10 log 1000 milliwatt divided by 2.5 milliwatt equal to 26 dB. So 26 dB return loss, the VSWR, we can calculate based on this formula is 1.106, slightly higher than the alternator's VSWR 1.08, but it's still good to be used as a dummy node for a short time. But this is not recommended for long term. So if you only temporarily use it, yes, you can use the alternator with the right conditions to its dummy node. If you like this content, please like, subscribe, and share. Thank you. If you have any comments or you have any requirements or any topics like to discuss for the coming videos, please leave your comments. Thank you.